Welcome to the deep dive. We cut through the noise to get to the core of knowledge that really matters.
Glad to be here.
Today, we're asking something that sounds, well, almost too simple. What is a computer?
Right. Seems obvious at first.
Exactly. I mean, we're surrounded by them. You're probably listening on one right now.
Or have one controlling your thermostat, maybe.
For sure. But how often do we actually stop and think about what makes these things tick? What fundamentally defines a computer, no matter what it looks like?
That's the core question.
So our mission today is to really unpack that definition.
Well-
We're not just going to read it out.
No, we want to get into the components, the different shapes they take.
And, what makes different types unique. Understanding this isn't just about learning tech terms.
Not at all.
It's genuinely a shortcut to, well, feeling more comfortable and informed in this digital world we live in.
And that understanding, it supports so much, doesn't it? It's the base layer for loads of modern skills.
Like what specifically?
Well, think about learning new software for your job. Or even just basic stuff like Microsoft Office.
Okay.
Or things like online safety, graphic design, even career planning sometimes. Knowing what a computer is helps you interact with all that technology more effectively. It's like understanding the engine, not just how to turn the key.
Right. Understanding the why behind it. Okay, let's unpack this then. When you hear the word computer, what's the first picture that pops into your head?
For most people, probably a desktop, right? Or maybe a laptop.
Yeah, me too. The classic tower under the desk or a sleek laptop.
But that image, it's actually pretty limiting when we talk about the core definition.
How so?
Because it focuses on the form, the physical shape.
Yeah.
The actual definition goes way beyond that specific box.
Okay, so what is that core definition then?
At its heart, a computer is an electronic device that manipulates information or data. That's the key.
Manipulates data, okay.
And its main abilities are to store data, retrieve data, and process data.
Store, retrieve, process. Sounds simple enough.
It does sound simple, but those three functions, store, retrieve, process, they're incredibly powerful and universal.
Universal how?
It means that, from the earliest massive calculating machines right up to today's experimental quantum computers, the basic interaction with information is the same.
Just much, much faster and on a bigger scale now, I guess.
Exactly. Exponentially faster. It's like the digital DNA of all these devices.
Digital DNA, I like that. Because just from storing, retrieving, and processing data, we get everything we actually use computers for. Typing documents, sending email, browsing the web, playing
All
games.
those everyday tasks.
But also more complex things, right? Like editing video or creating these really sophisticated spreadsheets for finance.
Presentations, yeah.
All of it, it just boils down to the device managing information in those three ways. Store, retrieve, process.
It's quite elegant, really.
It really is.
Yeah.
The sheer versatility that comes from such a simple core idea is amazing.
Yeah.
So if the computer is this digital brain handling data,
Yeah.
what makes it work? What are the essential parts?
Now we get to the fundamental duo, hardware and software.
Right. The two sides of the coin, you can't have one without the other.
Precisely. They're completely interconnected. Let's start with hardware.
Okay.
Hardware is any part of your computer that has a physical structure, stuff you can actually touch.
Like my keyboard or the mouse.
Exactly. The keyboard, the mouse, the monitor you're looking at, those are peripherals.
Peripherals, right.
But hardware also includes all the critical internal parts, the guts of the machine.
Like the processor. The
Yeah,
CPU.
the central processing unit, the CPU. That's the real brain executing all the instructions.
Okay.
Then you have RAM, random access memory. Think of that as the computer's super fast short-term memory for whatever it's actively working on.
Got it. Active tasks.
And then storage drives like SSDs, solid-state drives or older HDDs, hard disk drives. That's the long-term memory for all your files, your programs, everything.
So CPU for thinking, RAM for juggling current tasks, storage for keeping everything long term.
That's a good way to put it. Understanding how those bits of hardware work together is key to understanding performance.
Okay, so that's the physical stuff. What about software?
Right. If hardware is the body, software is the mind. It's any set of instructions that tells the hardware what to do and how to do it.
Instructions. Okay.
And we can kind of split software into two main groups. First, there's the operating system.
Like Windows or Mac OS on Apple computers.
Exactly. The operating system, or OS, is the master controller. It manages all the hardware, talks to the CPU, manages memory, and gives everything else a platform to run on.
So it's like the foundational software.
You could say that, maybe like the subconscious, handling all the background stuff needed to keep things running.
Okay. And the second type?
Applications or apps. These are the programs you actually interact with directly to do specific things.
Like my web browser,
Yeah.
or game, or a word processor.
Perfect examples. Those applications use the operating system, which in turn tells the hardware what to do. Think of apps as your conscious actions, built on top of the OS and hardware.
That distinction makes a lot of sense, and you really need both.
Absolutely. They're completely symbiotic.
Like right now, you're probably listening to this deep dive using some kind of app, right? A podcast player or a web browser.
Uh-huh. That's the application software.
And that app is running on your operating system.
Also is managing the hardware.
Like your speakers or headphones to actually produce the sound. And maybe you used your mouse hardware to click play.
And the software interpreted that click as the instructions so you'd start playback.
It really shows how everything you do, every single click or tap,
Yeah.
relies on that constant conversation between hardware and software.
It's a seamless dance, usually. Without the software instructions, the hardware just sits there.
Inert.
And without the hardware, the software has nowhere to run. It's just code.
Okay, so we have this definition. Electronic device stores, retrieves, processes data, and it needs hardware, the physical parts, and software, the instructions.
The essential partnership.
So, taking all that, what does it mean for how we should think about computers day to day? Because if we just picture that desktop or laptop,
We're missing a huge part of the picture.
yeah, it feels like we need to broaden our view of what actually counts as a computer. It's definitely moved beyond just the box on the desk.
Oh, absolutely. The word computer covers a much, much wider range of things than just those personal computers.
Okay.
Computers come in, well, all sorts of shapes and sizes now. They perform tons of different functions, often completely hidden from view.
Hidden how?
Think about embedded systems. Tiny, specialized computers built into other devices to do one specific job.
Like what?
Like the processor inside an ATM that handles your transaction when you withdraw cash.
Ah, okay. I never think of an ATM as a computer, but it is.
It definitely is. Or the system that scans your groceries at the checkout.
Right, that makes sense.
Even a modern calculator is basically a very specialized computer designed just for math.
Huh. So they're kind of woven into everything.
Pretty much, doing their jobs without us really noticing them as computers.
That's fascinating. But let's circle back to the ones we do usually think of as computers, the personal ones. We should probably cover the main types.
Good idea. Start with the familiar.
Okay, first up, the desktop computer. The classic.
The workhorse.
Yeah, often found at work, home, school, designed to stay put, really.
Right, they're usually modular,
Meaning?
meaning the main parts, the computer case itself, the monitor, keyboard, mouse, are all separate pieces.
Ah, so you can swap them out or upgrade them more easily.
Exactly. Offers a lot of flexibility for customization and upgrades.
Okay, desktops. Then we have laptop computers. Super common now.
The key word is portability.
Right. Battery powered, all the main components, screen, keyboard, processor, everything built into one folding unit.
Lets you take your computing power pretty much anywhere. Coffee shop, airplane,
Your couch,
Yeah.
yeah, turns anywhere into a potential office.
or entertainment center.
True. Okay, then even more portable. Tablet computers. Tablets. Like iPads and similar devices.
These are handheld, generally lighter, thinner than laptops.
And their defining feature is that touch-sensitive screen.
Right. You use your fingers for typing, for navigating.
Yeah,
No need for a separate mouse or keyboard most of the time.
makes interacting with stuff feel very direct, very intuitive.
Definitely. Desktops, laptops, tablets, those are the main personal computer forms, I guess.
Loosely, yeah. But there's another crucial type, often working behind the scenes. Servers.
Servers. Okay, what's their deal?
A server is basically a computer, often a very powerful one, whose main job is to serve up information or resources to other computers over a network.
Serve up information, like websites.
Exactly. Whenever you browse the internet, visit a website, stream a video, you're actually fetching that data from a server somewhere out there.
So servers are the backbone of the internet
Absolutely. And businesses use them too, like local file servers.
for sharing documents and stuff internally. Yeah, managing shared files, running company applications, databases. They keep things centralized, secure, and accessible for employees.
The unseen workhorses enabling everything else.
Pretty much. Silent, powerful, always on.
Okay, so we have personal computers, servers.
Right.
But you mentioned earlier that lots of other electronics are basically specialized computers too.
Right. The ones we don't usually label as computers.
Let's touch on a few of those other types because the specialization is interesting.
For sure.
Like smartphones, obviously more than just phones now.
Oh, way more. They're incredibly powerful mini computers we carry everywhere.
You can browse the web, play complex games.
And think about all the sensors packed in, accelerometers, GPS, amazing cameras.
Constantly gathering and processing real-world data.
Yeah, doing sensor fusion for things like augmented reality or really accurate navigation, all powered by tiny, efficient processors.
Okay. What else? Wearables.
Right. Things like fitness trackers, smartwatches.
Designed to be worn, obviously. Seamless integration into daily life.
And what's cool here is the focus on ultra-low power consumption.
So they can run for days.
Exactly. While continuously collecting biometric data, heart rate, steps, sleep patterns.
And analyzing it.
Often, yeah. Using specialized AI to give you health insights, all while sipping battery power.
Impressive. Okay, another specialized one. Game consoles.
Yes. PlayStation, Xbox, Nintendo Switch.
Built primarily for playing video games on a TV.
But under the hood, they are seriously optimized computers.
Mm.
Especially the graphics hardware.
GPUs, graphics processing units.
Yep, hugely powerful GPUs designed specifically to render incredibly detailed 3D worlds and manage complex game physics in real time. Pure entertainment machine.
Purpose-built computing power.
Definitely.
And even TVs themselves now.
Right, smart TVs.
Many have their own operating systems, apps.
Letting you stream Netflix, browse the web, access online content directly.
So the TV is processing data, running software. It's basically acting like a specialized media computer.
It really is. Some are as complex internally as basic desktop computers were not long ago.
It really drives home the point. Once you understand the core concept store, retrieve, process, you see computers everywhere doing all sorts of specialized jobs.
You really do.
Okay, let's zoom back in on personal computers for a minute. Desktops and laptops mainly.
Okay.
Because there are really two main, let's call them styles or philosophies that people often have strong feelings about.
You mean PCs versus Macs?
Exactly. You hear people saying, I'm a PC person, or I only use Macs.
Definitely a long-standing rivalry, or at least distinction.
So let's define them. What's the deal with PCs?
Okay, PC stands for personal computer, obviously. But its common usage really traces back to the original IBM PC, launched way back in 1981.
A landmark machine.
Hugely influential. It led to other companies making compatible computers the IBM PC compatibles.
Which just became known as PCs.
Right. And today, PCs are easily the most common type of personal computer globally.
And they usually run Microsoft Windows, right?
Typically, yes. The dominant operating system on PCs is Windows.
What's the underlying philosophy there?
Often, it's about openness and modularity. You have many different companies making PC hardware, Dell, HP, Lenovo, Asus, plus countless component makers.
So lots of choice.
Huge choice. Leads to lots of customizability, easy upgrades, and generally a wider range of price points and specifications.
Okay, openness and choice for PCs. What about Macs?
Macs, or Macintosh computers, were introduced by Apple in 1984.
Another historic moment.
Big time. The first Mac was the first widely sold personal computer to feature a graphical user interface, a GUI.
Boo.
Pronounced GUI, yeah. Instead of typing text commands, you had icons, windows, a mouse pointer. Revolutionary for making computers user-friendly.
Made them much more approachable.
Definitely. Now, the key thing about Macs is they're made by only one company, Apple.
Right. Hardware and software from the same place.
Exactly. And they almost always run Apple's own operating system, which is now called Mac OS.
So what's the philosophy there?
It's more about a highly integrated ecosystem. Hardware and software are designed together from the ground up.
Aiming for seamless operation.
Yeah, often prioritizing things like user experience, design aesthetics, and a generally streamlined, perhaps simpler approach. Tight control over the whole package.
So PC is open, diverse, customizable. Mac is integrated, streamlined, controlled by Apple.
That's a pretty good summary of the general philosophies.
And both are fully functional computers, capable of doing all the things we talked about, storing, retrieving, processing data.
Absolutely. Both are incredibly powerful tools.
They just offer a different look, a different feel, and represent those different approaches to computing, open versus integrated.
And people definitely develop strong preferences based on which approach resonates more with them or suits their needs better.
Makes sense. It's not just about which logo is on the box. It reflects those deeper design choices.
For sure.
Wow. Okay, so that brings us towards the end of this deep dive. We started with that simple question, what is a computer?
And found it's not quite so simple.
Not at all. We've hit the core definition store, retrieve, process data. We looked at the vital link between hardware, the physical stuff, and software, the instructions.
The essential doula.
Explored the amazing variety of computer types way beyond just desktops and laptops, servers, smartphones, wearables, even ATMs and TVs.
See them everywhere now?
And we just touched on those two main styles in personal computing, PCs and Macs, and their different philosophies.
Openness versus integration.
Right. So how does pulling all this together actually help someone listening?
Well, I think this kind of foundational knowledge is genuinely empowering. It helps you move past just using technology.
To actually understanding it a bit more.
Exactly. Understanding the architecture underneath. Whether you're trying to get better at your job, learn new creative tools, or just feel more confident navigating online life. Having this clearer picture demystifies the tools. You see the logic behind the screen.
It takes away some of the magic and replaces it with understandable principles.
Precisely.
You know, what I find really fascinating here is thinking about how that concept of computer has shifted.
How so?
From that single, maybe room-sized machine decades ago, to a big box on a desk, to now, this almost invisible force everywhere.
Woven into the fabric of life.
Yeah. So, thinking about that core definition, store, retrieve, process data, here's a final thought to ponder.
Okay.
What new specialized computers do you think are emerging right now or might pop up in the near future that we maybe don't even recognize as computers yet?
Good question. Things we don't have a name for yet.
Maybe. How will that fundamental definition keep stretching and adapting to cover whatever comes next?
That is something to think about. Where does the definition blur?
Exactly. Something for you to mull over. Until next time on The Deep Dive.